Hi, welcome to another edition of Math Made Easy. I'm Professor C, and today we're going to dive into scientific notations, just the basic skills. Now, I know many of you guys may have learned how to move the decimal and whether it's going to be a positive or a negative number. I want to take a different approach. I want to forget about some of those rules and just think about it logically. So on the board, I wrote down simply, large numbers should have a positive exponent, and small numbers should have a negative exponent. And we're going to dive into what that really means so you guys can get it really, really simple. Okay, here we go. Let's say, for instance, I had a really large number, and I'm talking about any number greater than 10. Okay, now that could be a positive integer or a negative integer. It doesn't really matter. Just if you see a very large number or a number that's greater than 10, we're going to call that a large number. So for instance, let's say for instance, we have okay, 25,473,078. Okay, as you can see, this is a very large number. Okay, our goal is to put it into scientific notation. That means the coefficient should be a number between 1 and 10, and the exponent has a base of 10, and there's going to be a positive exponent. Now, some students may say, well, I don't see a decimal place or a decimal point. Remember, think about it like money. Where would the decimal point be in this number? Would it be here? Would it be here? Would it be down here? I think it will be at the end of the number, because this will represent money, right? Think about it like that. Imagine if this was money, okay? Do you now see where the decimal place would be if it's not shown initially? Great. So let's go ahead and dive into how to move this decimal to make sure that it is a number between 1 and 10, okay? If I have my decimal here and I move it to this place, is this a number between 1 and 10? No, I must keep going. So let's keep going. So I moved it one place, 2, 3, 4, 5, 6, 7 places to make sure I have a number between 1 and 10. Remember, 1, 2, 3, 4, 5, 6, 7 places. I moved it 7 places, okay? That's why the exponent is 7. And we moved 7 places, okay? Now all we have to do is rewrite our number as the coefficient. And I'm gonna write that in green for you, okay? So the number is 2.5473,078. This number is now rewritten in scientific notation. That's a very large number. Now let's look at very small numbers so you can see what I mean by that. A very small number is any number that is smaller than 0, okay? That means the zeros in the ones place, okay? So let's imagine I had this number. You should recognize that this is a very small number because the decimal place, and this is some value that's lower than 0, okay? And in this case, we're going to end up with a negative exponent, okay? So I'm already going to write that down. I know I'm going to have a negative exponent, but I'm still counting how many places I'm moving my decimal. So my decimal is here. I'm going to move it 1, 2, 3 places, because the goal is to have one digit to the left of the decimal. That means one digit in the ones place, okay? So now that I made that, move that decimal, I can rewrite this number, okay? Moved it 1, 2, 3 places. That means this number in scientific notation is 7.3408. times 10 to the negative third power. Okay, let's try one more example, and I'll leave that one above. Let's say, for instance, I have this number. Okay. Again, a very small number means I have a what? Negative exponent. Okay. So I'm going to write that down. So I know that already. Now, let's go ahead and count how many decimal places do I need to move it in order for me to have one number in the ones place. Okay. 1, 2, 3, 4, 5, 6. Do you see how that's one number in the ones place? Okay. So now I can just rewrite this number as 8.26 times 10 to the negative 6 power. Okay. I shouldn't move it, because some kids may ask, well, why don't I move it all the way over? Okay. If I moved it all the way over, do you realize that now the decimal will be here and you end up with a number that has 826. That's going back to become a big number. We only want our coefficient to be a number between what? 1 and 10, or really 9.9, or any number just right below 10, okay? So remember, you only want one digit to the left of the decimal place, all right? So, in summary, the basics of scientific notations is large numbers are represented with positive exponents. Okay? Very small numbers, as you guys can still see on the board, are represented with negative exponents. You're still counting which direction you want to get so you can have one digit to the left of the decimal. And again, this is Math Made Easy with Professor C. I want you guys to enjoy your day.